This is lesson 6.2, simplifying expressions with rational exponents. Last lesson we talked about rational exponents and how to create rational exponents and how to change rational exponents back into radical exponents. Today we're going to simplify problems, and basically I just have a whole bunch of examples for you. So let's start with the first example. 7 to the 1/3 power times 7 to the 4/3 power. Remember that if we have 7 as our base, then we add 1/3 plus 4/3, and that gives me 7 to the 5/3 power. If I'm dividing and I have 4 to the 2/3 divided by 4 to the 1/3, again 4 is my base number, and I subtract now my exponents. So 4 to the 2/3 minus 1/3 becomes 4 to the 1/3 power. Those are a couple of fairly simple basic ones. If I have 6 to the 2/3 power to the 3/4 power, remember that you are multiplying the exponents, and you top to top and bottom to bottom. So this is going to be 6 to the 6/12 power, but 6 over 12 reduces, so this is 6 to the 1/2 power, which actually means the square root of 6. So if you wanted to write it that way, you could write it as the square root of 6. So when you add, let me try that again. Let's go back a couple pages. So first example, if you have multiplication, you add the exponents. If you have division, you subtract the exponents. And if you have a power next to a power, you multiply the exponents. What do we do in this case where it's 5 to the 1/4 times 3 to the 1/4? Well, this doesn't work the same way because these are not the same base number. 5 and 3 are not the same base. So instead we have to look and see that they have the same exponents. So in this case, instead of combining my powers, I'm going to combine my bases. So this is really the 4th root of 5 times the 4th root of 3, which is the 4th root of 15. And I wrote this in radical form, but you could just as easily have said this was 15 to the 1/4 power. And that would also be correct. Either way would be fine. For this next example, I have the 4th root of 2 times the 4th root of 8. Again, 2 and 8 are not the same base, so I cannot combine the bases, but they are the same root. So since I have the 4th root and the 4th root, I have the 4th root of 2 times 8, which is 16. So you could write that as 16 to the 1/4 power. And this actually has more, it goes a step further, because 16 to the 1/4 power is 2. Because if I multiply 2 times 2 times 2 times 2, if I have 4 2's, it actually gives me 16. So that 16 to the 1/4 power, or the 4th root of 16, equals 2. On this example, I have 11 divided by the 4th root of 11. So again, this is my base that's the same. So this is 11 to the 1st power over 11 to the 1/4 power if I write it in rational exponent notation. So then this is a division problem, so I take 1 minus 1/4, and 1 minus 1/4 is 3/4. So I have 11 to the 3/4 power as my solution. If I have the 4th root of 192 divided by the 4th root of 6, 192 and 6 are my base numbers. They are not the same, but my exponents are the same. So this is going to be the 4th root of 192 divided by 6, and I can actually simplify that. 6 goes into 192 32 times. 6 times 32 is going to be 192. So this is the 4th root of 32. And that's going to be my solution. All right, now we're going to continue the same problems. It's just that now we're going to have variables. So in this problem, I have x to the 5/3 times x to the 4/3, and that's x is my base, so I keep the base, and I add 5/3 plus 4/3, and 5/3 plus 4/3 is going to be 9/3. Well, 9 over 3 reduces to 3, so the answer here is actually x to the 3rd power. The next example is the square root of x to the 2/5 power. This problem would be really hard if we didn't rewrite it, so I'm going to start by writing this as x to the 2/5 power to the 1/2 root, because a square root can be written as a power of 1/2. When you look at it in this form, then you can see I have to multiply 2/5 times 1/2, which makes that be 2 over 10. And 2 over 10 reduces to 1 over 5, so my solution is x to the 1/5 power. Or if you wanted to, you could write it as the 5th root of x. For this example, again, I have x to the 1/2 power to the 2/7 power, and I'm going to multiply my powers. So 1/2 times 2/7 is 2 over 14. And 2 over 14 reduces to 1 over 7. So x to the 1/7 power, or the 7th root of x, whichever you prefer. All right, now some of these problems get a little bit more complicated, so let's look at this problem, and let's look at it individually. I have x squared to the 1/3 power over 27 to the 1/3 power, because both of my insides of this parenthesis are to the 1/3 power, so they both are to the 1/3. So in the numerator, I have x to the 2nd power times the 1/3 power. That becomes x to the 2/3 power, because you put your 2 over 1 and you multiply straight across, you would get 2/3. The denominator is 27 to the 1/3 power, which means the cube root of 27. If it doesn't simplify, I wouldn't simplify it, but in this case it does simplify. 3 to the 3rd power is 27, so the cube root of 27 is 3. And this answer is x to the 2/3 over 3. And then probably the most complicated problem, I think, in the whole workbook assignment page is this problem. And we're going to simplify it by dealing with the top, and then once we have the top simplified, then we're going to subtract the exponent since it's a division problem. So let's start out by changing the top. This is 64 to the 1/3. This is x to the 3rd to the 1/3, and this is y to the 1/3 power. Each of these is to the 1/3 power because it's the cube root of all of them. In the denominator, I have 4x to the -3, and I have y. That part's not simplifying yet. All right, now my numerator will go a little further. The cube root of 64 is actually 4, because 4 times 4 is 16, and 16 times 4 is 64. Now when you look at this one, x to the 3rd to the 1/3 power, 3 times 1/3 is just 1. So it becomes x to the 1st power. And y to the 1/3 power is going to stay y to the 1/3 power. I'm rewriting my denominator exactly the same because I haven't changed it yet. Now I'm going to look for things that will simplify, and you can see these 4's are going to cancel each other out. With the x's, this is x to the 1st power minus x to the -3rd power, so I subtract 1 minus -3, and for y it's going to be 1/3 minus 1, because the y in the denominator is to the 1st power. So what I'm left with now is x to the 4th, y to the -2/3. And if you recall from when we did exponents before, you don't ever want to have a negative exponent. So the negative part, I'm going to move to the denominator and make this x to the fourth over y to the positive 2/3 power. That's as simplified as that problem's going to get. It is a lot more simple than it started, but it's not super simple. So those are the examples for you. Your assignment is page 98, 1 through 24 all. Again, this is a short assignment. Once you count out the 12 problems that I worked for you, you only have 12 problems to do. So work this one, and then you're ready for the next lesson.